NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report. Although it may look like a typical aircraft landing, the pilot never left the ground. This is a takeoff and landing simulator at NASA's Ames Research Center near San Francisco. It is one of several such devices which closely duplicate the motion and feel of a plane in flight. It works like this. A closed-circuit color television system incorporated into a scanner moves across a mock-up of an airport approach and runway, showing the pilot what he would see if he were really making the landing. The color image is projected on a screen mounted in front of the simulator cab, giving the pilot a very realistic view as he approaches to land. The entire system is controlled by and tied into computers. Every move the pilot makes, every motion of the aircraft is recorded for study.
Computer is ready for run 1.
Okay, here we go.
At Ames, modern simulators are essentially a research tool. The primary purpose is not to teach the pilot, but to learn from him. From these simulators will come the refinement of aircraft design and improvements in handling quality.
That looks good. Reset.
Take a look at this thumb control, designed to control the spoilers on a plane's wings, causing the aircraft to ascend and descend. Normally operated by a lever beside the throttles, the small thumb control made it easier to handle the plane both in flight and during landing. After being thoroughly tested in simulator runs, the small device was installed on a big 990 jet. When the spoilers were lowered using the thumb control, the aircraft ascended. When raised, it descended again. The response was prompt and the system worked well, confirming the results of the ground tests. Aircraft simulators, helping make improvements on planes in use today and laying the basic research groundwork for aircraft of the future. How do you design a spacecraft to go to Mars and, once there, determine if any form of life exists? It is believed that hot, dry deserts in our country and elsewhere, and the cold desert areas of the Antarctic, may be key locations in helping scientists to learn more about the probability of life on Mars. It is in these places that scientists like Dr. Roy Cameron and his colleagues at NASA's Jet Propulsion Laboratory in Pasadena have made extensive studies.
The reason for investigating the deserts on our own planet is because Mars itself is expected to be an extremely harsh kind of desert environment. Therefore, we want to gain background information and data and test samples for the design and use of possible extraterrestrial life detectors. Now, when we go into the harshest deserts of our own planet, there is no visible life. If there is any life at all, it is microscopic life, and it's in the soil. Therefore, Martian life detectors are being designed to look for life not just on the surface, but under the surface.
Soil samples gathered from deserts around the world are returned for analysis. From these tests, it is hoped we will learn not only how to detect life on Mars, but what man's presence might do to the red planet. This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.